Alright, so we're going to be finding the volume of circular shapes, and these are going to be very much like the prisms that we were working on earlier in the month. So if you remember back to your prisms, they were volume equals big V times big H. And that's because we had two bases that matched at one and the opposite side of the shape, and then they're connected by the height. And so we always went in and we changed this to whatever formula we needed to find the area of the base. And then the big H is the height, but how do you find the height? It's the distance between the bases. So this is going to be the same exact idea, except the shapes that we're looking at are going to be circular shapes. So they still have two bases, the top and the bottom in this case. Even if it's turned on its side, the bases are the two opposite sides that match. So it's basically the same formula, big V times big H. But if you look this up in a geometry textbook, this is not going to be the formula that's stated. It's going to be this same formula but turned into a circle. So big B, to find the area of the base, how do I find the area of a circle, is pi r squared. So we're going to change big B to pi r squared, and then we still have to times that by the height. Now there's only one height, because to find the area of a circle there's no height involved. So if we want to keep this as a big H, that's fine. But in a geometry textbook it's going to come up as a little h. It really doesn't matter, uppercase or lowercase. It's the only reason we use a capital sometimes is just to differentiate, because there's more than one height in the problem. So whether you use a big H or a little h, it doesn't matter. So all we have to do now is come over here. We're going to find the radius. They're either going to give you the diameter, which is the measurement all the way across the circle, or the radius. We're just going to plug that number in, square it, times it by the height, times it by pi, and we're done. So in this specific one, this cylinder, the radius is given, it's 2, so we're going to plug that in. So pi times 2 squared. And then the height is the distance from one base to the other, so from one circle to the other circle, and so that's just 12. You could plug all of this in your calculator at one time, or you could do it piece by piece. You could go straight from this to your final answer is fine. I'm going to do it in a couple pieces just for your notes. So 2 squared becomes 4, so it's pi times 4 times 12. Again, all of this can go right in your calculator right now, or you can do it piece by piece. Multiplication can be done in any order, so I'm going to do 4 times 12 and get 48. And then 48 times pi will give me a decimal that I need to round. We'll just do nearest tenth, because that's what we're used to, so 150.8. And we want some units. This is feet, and volume is always to the third power. Alright, so these are cylinders. Let's make sure we have that vocabulary word. So cylinders in everyday life you could think of as a can of soup, depending on if it looks proportional to that. And volume is finding out how much fits inside. So how much soup can you fit in the can, or something along those lines. That's what we're solving for. So same thing here. This is just a cylinder turned on its side. So it's big B times big H, which we're going to turn into area of the base pi r squared times the height. For this one now we need to be careful. We need the radius, but they've given me the diameter. They've given me distance all the way across, which is 10. So that means halfway across, if I split this into two pieces, is 5 and 5. So the number that I'm plugging in for radius is not 10, it's 5 squared times the height. Now, we always want height to be up and down, but depending on which way you turn the shape, it may or may not be. It's always the distance between the bases, which in this case are the circles, so the height is 11. So pi times 5 squared times 11. You can go straight to your final answer at this point. I'm going to do it in a couple pieces just to demonstrate. But you could go right to your answer. 5 squared is 25, right? Not 10. Times 11. 25 times 11, if I'm going to spread this out into a couple steps, is 275. And so I'm going to multiply that times pi and round it. So I get 863.9. The 3 that comes after the 9 tells me I can just leave it alone. So final answer here, 863.9 miles to the third power. Alright, so the only other one we're going to cover today are the cones. We're going to leave the spheres for another day. So the cones are very much like a cylinder. If you had a cylinder, you don't have to draw this if you just watch. So you have a cylinder which is just two bases that are the same, connected, they're both circles. If we wanted to turn it into a cone, we would leave this base on the bottom, and instead of the sides coming up straight and forming into another circle on the other side, if we have them come to a point, we now have a cone. And just visually, if you look at this, it's kind of cutting this into three triangles. Okay, you've got your triangle here, your triangle here, and your triangle here. So this is 1/3 of the size of your cylinder. So our formula is 1/3 big B times big H. So it's the same exact formula, except it's 1/3 of the size. It couldn't be the same size because it would hold more liquid or more air or whatever. If it went straight out, since it's coming to a point, it's going to hold less. It's exactly 1/3 less, and the way I always remember it is if I just draw it or just picture it mentally. It's cut this cylinder into three triangles, so it just helps me remember that it's going to be 1/3 of the size. So in the geometry textbook, it's not going to use big B and H. It's going to replace big B with the area of the base. So since it's a circle, pi r squared times the height, and it's going to use a lowercase height. So this is what you'll see in a geometry textbook, 1/3 pi r squared times the height. Now to deal with the 1/3, we're going to save it for last. It's the same as just dividing by 3. It's 1/3 of the size. So timesing by 1/3 and dividing by 3 is the same. So we're basically going to run this equation the same way we did up top for the cylinders, and the last thing we're going to do is just divide by 3. Cut that volume in 1/3. Alright, so let's plug everything in. 1/3 stays, pi stays. We just need to plug in for radius and height. So my radius here, halfway across, is 12. It's given to me. So I don't need to double this. I don't need to cut this in half. This is the radius. So 12 squared. And the height is going to go from the point at the top of the cone to the base. So 24. If you know how to plug this in your calculator, you could plug this all in at once, but this is where I would really recommend that you don't, because being able to handle that 1/3 is important. So let's do it piece by piece here. 12 squared, you could do in your calculator 12 times 12. That's 144. You still got to multiply that times the height. So 144 times 24. Calculator will handle it for you. So it's 3,456. And the rest we're going to do in the calculator. So here's what I recommend. I recommend that you multiply by pi first. So we're going to do pi times 3,456. We're going to get that answer. Don't even need to write it down right now. This is what it would be if it was just a cylinder. So to make it a cone, we have to take 1/3 of that, which is the same as dividing by 3. So after I multiply by pi and I've got this long decimal, I'm just going to hit divide by 3. And that will get me my final answer. So the last step is the only thing that's different between the cone and the cylinder. You're going to do pi times the radius squared times the height, and then at the very end divide by 3. So volume is 3,619 point. We're going to leave it as 1. And this is yards to the third power. Alright. One more. So it's always big B times H. It's 1/3 of the size because it's a cone. We've cut that cylinder kind of into 3 pieces, 3 equal pieces. So we're going to replace big B with pi r squared, because that's how you find the area of the base, find the area of the circle. This picture has given me a diameter of 22, so I'm not going to plug 22 in for the radius. I need half of it, so it's 11. So when I plug in, pi times 11 squared, and the height here is clearly 22. Alright, let's run these numbers. So I'm going to leave the 1/3 and the pi alone, save those for last. 11 squared is 121, just 11 times 11. Once I've got that, I'm going to times that by 22, which comes to 2,662. At this point, I'm going to do the rest in the calculator. So I'm going to save the 1/3 for last. I'm going to do pi times 2,662. You don't need to write that number down. Just leave it in your calculator and take 1/3 of it, which is just divide by 3. Final answer, 2,787.6, and the 3 tells me I can leave it alone. Yards to the 3rd power.